Yeah, very good afternoon. This is Sandeep Chaitanya, coordinator for the FDP program. Welcome to the first day's second session. So morning, you have enjoyed a lot about the session. And now let me introduce today's speaker, Dr. Venkatesh Rao Garu from NIT Warangal. Sir, are you there? Venkatesh Rao Garu? Sir, can you unmute your mic, please?
Yeah, shall we start? Thank you very much.
Yeah, yes, sir. Okay,
Yeah.
before handovering the session to Venkatesh Rao Garu, it's my privilege to introduce Venkatesh Rao Garu. He's working as an assistant professor in the Department of CSC, NIT Warangal. His area of interest are mainly about the machine learning, deep learning, and data mining. He obtained his PhD from HCU, University of Hyderabad. His research areas interest are data mining, machine learning, as I said right now, with a specific focus on machine learning techniques for recommender systems. His work has been published in various reputed journals, conference proceedings such as patent recognition letters, information sciences, expert system with application, Journal of Approximate Reasoning, AI, and different type of things. He delivered various guest lectures in several international and national workshops organized by NITs and IITs. So it's our privilege to have you, sir. Over to Venkatesh Rao Garu.
Thank you. Thank you very much. Yeah, very good afternoon, Miranda. In this section and in the next section, we're going to cover the various Python basics that are required to write the machine learning or artificial intelligence related or data science related programs or to implement the data science or machine learning algorithms. All right. So the software installation instructions have been already been shared with your course coordinators, FDP coordinators. They will
Yes, sir. It
share with
has
you.
been already shared, sir.
Already shared with them. Okay,
Yes, sir.
good.
Yes, sir.
So you might not have got time to install it. It's okay. Even if you don't install, I'll tell you the alternative way of executing these programs that I'm gonna demonstrate. Okay. So by chance, if you have already installed the Jupyter notebook, I'll show you how to open it. So go to the search bar. Search bar is here, right? In the bottom left corner. Or you can press Windows plus S. You'll go to the search bar. Then type Jupyter notebook. Then you'll see something like this. Click on it. I hope my screen is visible. Whatever I'm demonstrating, you could see that. Is it?
Yes, sir.
Yeah, thank you. So then one window will something like this will be opened in your browser. So now go to the appropriate folder. This is in the root folder. So I just want to execute this program in downloads folder. Okay, so I'm going to the downloads folder. So similarly, you can go to wherever you want to put your program, keep your program. Okay, so here, if you want to create a new folder, go to new and click on the folder and rename it. Okay, so as I have already have the appropriate folder for this purpose, I'm directly selecting that. Okay, where is this? Oh, sorry. Yeah, so here it is. So if you want to open a new Python file, Python 3 file, go to this new part and then click on Python 3. And one tab will be opened here. So this is the untitled file where you can write your program. So you can give an appropriate name for this. So here I'm going to the menu bar file and then rename it. So I'm just giving some name for it. So Python day 1. Okay. So I'm just giving some name and renaming it. Now I'm ready to execute my program. So if you want to give some annotations or some description about the program that you're going to write or whatever the statements that you're going to write, then you can go to the menu bar again, click on cell, click on the cell type, then click on the markdown. So here you can give, if you want to give any headings or annotations. Okay, so here you can give, I'm just giving some third level heading. just putting some heading Python basics. So here you can give some list also. I'm just giving some bigger data types, data structures, um, data structures, and then we're going to discuss the conditional statements, and then we're going to discuss the looping statements, and then if time permits, we'll see the other things, but mostly till we'll see the functions, how to write the functions. Okay, so these are all the things that we're going to cover in today's session. Okay, so if time permits, we'll see the NumPy, Python, NumPy, Pandas, and Matplotlib libraries also. Otherwise, we'll see them tomorrow. So this is the agenda for this today's section, right? So if you have not installed the Jupyter notebook, don't worry about it. Okay, so go to the search bar. Okay, in the Google, you can type Google Colab, Google Colab, and click on very first link. Okay, just click on the first link, which is this. I hope I'm audible. I'm audible.
Yes, sir. Yes, sir.
Yeah. So you can just click on side by, then go to the file and click on new notebook. Click on new notebook. You'll see the Jupyter like file here. So whatever that I'm writing in the Jupyter notebook, you can execute in the Google Colab as well, right? So for example, the same thing, let's say here I've written something, right? Let me copy this. Okay, you can give some appropriate name here by clicking on this. You can give some appropriate name, whatever that you want to give here. All right. So here, if you want to give some annotations, you click on the text box here, right? Text cell. You can click on that. If you want to write a code, you click on the code cell here, right? So here, I'm just putting this whatever that I have written there. I'm just copy pasting here. You see that the same thing it is here. So whatever the code that you want to write here, you can write here. So like for example, if I would just want to add two numbers, a equal to 2 and b equal to 3, c equal to a plus b, a small thing, some simple thing I'm just demonstrating. See, so you can write this. So this will execute and print you this results, right? So the same thing, more comfortable in Jupyter Notebook because that takes a lesser time because this is doing this online. So it takes little more time than Jupyter Notebook, right? Whereas the Jupyter Notebook is running on the local server, right? So I'll be doing it in the Jupyter Notebook, but if you have not yet installed the Jupyter Notebook, you can do it in Google Colab. Okay, so let's proceed. So here is that. So we'll start with the data type. The type of the variable is automatically taken based on the value that you are assigning for that variable. Like for example, if I take a equal to 5, b equivalent to some let's say some 4.5. So you can just print both of them, print a and type of a, and similarly you can also print b and type of b. You see that it is automatically taking the type. One is the integer value, the other one is the floating point value, as you see there. Similarly, there are other data types that the Python supports, c equivalent to some, let's say 4 plus 5j, or you can similarly do this, print c and type of c. And similarly, what are the other data types that we generally see? Boolean data type, right? So I'm just taking some Boolean value, true or false. You can do the same for this also. Print the D and type of D. And you can also even take the strings. Okay, some string you can take. Okay, can print E and the type of E. See that in float, complex, boolean, and string. So depending on the value that you're assigning, it is automatically taking that type of the variable. Okay, so there are other inbuilt data types that the Python supports. Okay, rather we call them as the data structures for the better understanding of them. So we're going to see them now. So the primitive data types that the Python supports are lists, tuples, sets, and dictionaries. So we're going to see each one of them one by one. So why we use the data structures basically for the efficient storage of the data, for the efficient retrieval of the data, or for efficient accessing of the data, or updation of the data. So these are the operations that we usually perform on the data structures, right? How to create a data structure, how to insert the elements into the data structure, how to access the elements from the data structure, how to update the elements to the data structure, and how to remove the elements from the data structure, right? So creation, accessing, insertion, updation, and deletion. So these are the general operations that we perform on any data structure. So we'll see 4 data structures that Python supports: lists, tuples, sets, and dictionaries. So these are the data structures that we're going to see. We'll see each one of them one by one. We'll start with lists. Okay. So as I have mentioned, in this session, we'll be seeing only the basics, right? So we're going to see these concepts: data types, data structures, conditional statements, looping statements, and how to write your own functions. So in the next session, we'll see some of the libraries, inbuilt libraries, that are useful for implementation of this machine learning or data science related algorithms. So we'll start with list. The very first thing that comes into our mind is that how to create a list. Okay, and what is this list? The list can be, you can imagine it like an array like structure, right? So this can be created by simple assignment like we have done in the case of other data types. So I'm just creating one list here, L1 equivalent to 1, 2, 3, 4. I want you to make note of this, that we use the square brackets to create a list. Square brackets, if you are giving, it means it is a list. It considers that as a list. So this is a list of 5 elements. There is another way of creating the list. Okay, and that way we use it for the translation of the tuples to a list. All right. So another way that you can create a list is L2 equivalent to list of some, you can pass a sequence of elements 1, 2, 3, 4, 5, right? So you can, this also will do the same job. Okay, you can even print the type of this L1. So here it is, L2 and type of L2. All right. So you see that both of them creates the same type, same kind of list, 1, 2, 3, 4, 5. So this is the way that you can create a list. So the one operation is done. That is what, how to create a list. Now we'll see how to access a list, how to access a single element, how to access a slice of elements, how to access the list in the reverse order. All these things we'll see as we proceed. So the next thing that we're going to demonstrate is that accessing the elements. So we'll see how to access a single element first, then we will see how to access multiple elements at a time. Okay. I'm just giving printing this L1 for our reference. So 1, 2, 3, 4, 5. So how do we access the array elements? Can anyone tell me how do we access the array elements? If it is an array, how do I access?
Using
Passing the
index.
index number, right?
Yes.
We specify the index number, we access them. Similarly, here also we specify the index and we access a particular element in the list. And the indexing starts from 0 and set n minus 1, where n is the number of elements in the list. So if I want to access 1, then I can just call L1 of 0 square brackets, then it will access 1. If I give L1 of 1, then it will access 2. If I give L1 of 2, then it will access 3, and so forth. So this is how we can access the single elements. Okay, and this is what any other programming language also this is there, right? Positive indexing. In addition to that, Python also support the negative indexing. Okay, negative indexing means the you can access the elements in the reverse order also, like starting from the end element also you can access them. I'll show you how to do that. So if you give L1 of -1, it is referring to the end element. What is the end element in the list? What is the end element in the list? 5, isn't it? So it will print 5. Similarly, if I give L1 of -2, it will print last but one element, okay, which is 4. Okay, so similarly, can you tell me what it will print if I give L1 of -4? L1 of -4. What it will print? It will print 2, right? So this is the forward indexing and the reverse indexing. And there is another provision that the Python supports. Another feature that the Python support is that accessing the slice of elements at a time. So you can access the slice of elements at a time. So I'll show you how to do that, accessing a slice of elements. Okay, so again I'm printing this L1 for our reference. So this is L1. Suppose I just want to access 2, 3, 4. Okay, one slice, list of elements. Okay, then the slicing operation is done in the brackets L1 of open square brackets. Then starting index is 1, right? 2, 3, 4 means it is an index 1, and ending index plus 1, right? So ending index plus 1 is 4. So it means if you specify A is to B, it will start at the index A and it will access till B minus 1 index. It will start at index A and it will access till B minus 1 index. So it means here it is starting at index 1 and it will end at index 3. It means it is accessing the elements that are present at the locations or the indices 1, 2, 3. So what are the elements that are present at 1, 2, 3 locations?
2, 3, 4.
2, 3, 4. So it will print 2, 3, 4 here. So similarly, suppose if I want to access 3, 4, 5, what should I write here? Starting index is what? 2, and the ending index is 5. Right? So it will access the elements that are present at the indices 2, 3, 4. Right? It will start from A and it will end at B minus 1. Okay. So then 3, 4, 5. Suppose if I don't mention anything at this place, okay, so it is equivalent to mentioning 0 there. It means if you don't mention anything here, it will take it from the starting index, that is 0 index, right? So this will access the elements 1, 2, 3, 4. Okay. Similarly, if I don't give anything in place of B, suppose I just gave this one here and I didn't give anything, I just left it empty, then it will proceed to the till the end of the list. So it is starting at index 1 and it is proceeding till the end of the list. So it means what it will print? 1 is 2, 3, 4, 5, it will print. Okay, so if I don't specify anything in the place of A and in place of B also, then it will access all the elements of the list, individual elements of the list. So 1, 2, 3, 4, 5. Right, this is how slicing can be done. So you have an option to choose the step size also in the slicing operation. Like for example, let me take this. So let's say that I'm starting at index 0 and ending at index 5, which is equivalent to mentioning empty-ist, right? I mean, without mentioning 0, 5 also is the same. So you can mention the step size as 2. So if you mention the step size as 2, it will just access the alternative elements. You see that 1, 3, 5. All right. So if I mention the step size as 3, then can you guess what it will print? 1,
4.
4, right? It will print 1 and then 4. All right. So like that, you can mention the step size. So it will start at the starting index that you specify here, which is 0, and it will end at end index -1, which is it will end at fourth index. And every time it is taking a step size of 3. So it means after accessing the element that is present at the 0th location, 0 plus 3, then third location element it will access. Then 3 plus 3, 6. If it is not exceeding the end element, that end index that you specify, then it will access the sixth element. Otherwise, it will stop there, and so forth. Like this, you can access the elements by mentioning the step size also. All right. So that is about the slicing and the stepping function. How to access the elements by specifying the step size. This can be done even in the case of reverse indexing also. I can show you that. Okay. Yeah, let me just print L1 again for the reference. So this is L1. So now if I access print of L1 of -1, what it will print?
5.
It will print 5, the last element. If I give -1 is to -3, then it will not print anything, in fact. Okay, it is an empty list. But if I give -3 is to -1, then without mentioning any step size, if you don't mention any step size, by default it is 1. Okay, so -3 is to -1, then it will print 3 and 4,
5,
isn't
4,
it?
3.
3, 4. Okay, it is starting at index -3. Index -3 is 3, right? And it will end at -1 plus 1. Sorry, -1 -1, which is -2, right? Which means it will print 3 and 4. It is printing 3 and 4. So suppose if I mention -1 is to -3 and I give the step size as -1, and it means what? It is starting at -1, ending at -3, and the step size of -1, right? Then it will access these elements in the reverse order, 5, 4, right? 5, 4. If you give -2 here, and let's say you gave -5 here, then it is accessing 5 and 3 in the reverse order. All right. So like this, you can you can perform this slicing operation and the steps stepwise also in the reverse, even using the reverse indexing. All right. So far we have seen how to access the elements, right? Even I can show you how to create a nested list, and then later we will move to how to update the list, or how to insert the elements into the list, or how to append the elements into the list, or how to remove the elements into the list, or how to update the elements into the list, and also we'll see some built-in functions. Okay, so before that, let me show you how to create a nested list. Nested list means what? List of list, isn't it? So here I'm creating a nested list. Let us say L2. So L2 equivalent to, you can say, list of list 1, 2, 3, and another list 4, 5, 6. So it is a list of list, right? So this is one element in the outer list. This is another element in the outer list. So this is the list of list, right? So this is how we can create outer list. Nested list. So I'm just printing this. You can see that it is a list of list. So now how to access these elements in the nested list? Okay. So in the nested list, suppose if I access L2 of 0, what do you think it will print? L2 of 0. What is the 0th element in the outer list L2? in the nested list?
1, 2,
1, 2, 3.
Right? So it will just print 1, 2, 3 here. So in this list, suppose I just want to access a particular element, then I have to refer to this list, and then in that another element, let's say 1. Then what it will print? L2 of 0, 1.
2.
Second element in the first inner list, that is 2, right? So that is what it is printing. So similarly, the slicing operations also can be done in case of nested list as well. Slicing operations also can be done in case of nested list as well, right? So like for example, if I want to access, let's say 2 elements, 2 and 3, right? So you can start at index 1 and index, so it is accessing this 2 and 3, right? So the slicing can be done even in the case of nested list. Fine. And list can be of homogeneous, it can be of heterogeneous type also. It not necessary that you will always have the list of the similar elements, all ints, all floats, not required, right? You can have the list of heterogeneous elements. Like for example, here I am creating a list. Acha, do you want to try simultaneously or will you go through it later? I'm not copy pasting, that's why I'm asking. Do you want me to copy paste? Would you like to try simultaneously? Or I will share the file later. Which one is better? Is it okay if I share the file later? Or should you want me to copy paste everything?
So you can share it later, sir.
Okay, fine. Thank you, ma'am.
Okay.
Fine. Yeah, that saves time actually. And anyhow, you will not get time in between to execute it because I'm going little faster, right? To cover more concepts. Fine. So the list can be of heterogeneous type also. So like I can give some integer, some element as some floating point, some Boolean value, some complex number, let's say, and some what we left with strings. Okay. Or some a list again. It can be another list also. It can be another tuple also. So it can be of anything, right? So this can be of heterogeneous type. The list can be of heterogeneous type. It's not necessary that all the elements should be of the same type. Okay. Fine. The another one. Now, so far we have seen how to create a list, how to access the elements into the list, and how to create nested list, how to access them also we have seen. Now I'll show you how to add elements to the list. How to add elements to the list. Okay. So, or how to insert elements into the list. Okay. So let's say I'm just taking here L1. So 1, 2, 3, 4, 5. Let's say I just want to append. I just want to append one. Just reinitializing it here. I just want to append 6 to this. Okay, how do I do that? So L1 dot append and mention the element that you want to append. 6. Okay. So let me just print this after appending it. You see that after appending, the 6 is appended to the previous list, right? List of 1, 2, 3, 4, 5, right? So this is how you can append the elements. Even you can insert the element at a particular location in the list. So if you call append, it is appending this element at the end of the list, right? Suppose I just want to insert an element at a particular location, right? Not just at the end of the list, right? Then you have a function called insert. So you can call L1.insert. Let's say I just want to insert 0 at a particular location. At a particular location, let's say at second index, 2, 0, right? So at second index, I just want to insert 0. So it will be inserted at 0 location, and whatever the element that are present at the 0 second location earlier will be shifted to the right, and the consecutively the other elements also will be shifted to the right. So now you see that 0 is inserted at location 2, and the earlier whatever the elements that are present starting from the index 2 now shifted to index 3 and later, right? So it means these are shifted to one place, right? So this is how you can insert the elements at a particular location in the list, right? So now suppose if I just want to insert the elements, like for example, I just want to append not just one element, a list of elements, let's say, okay. I just want to append at a time 3 elements or 4 elements or n elements, right? So like for example, I just want to append 6, 7, 8 to this 1, 2, 3, 4, 5, so that the whole list will become 1 to 8. Okay. So how do I do that? Will the append work there? Let us see. Let us try L1 dot append, and I'm just appending a list of elements, not just one element. So I just want to append this list of elements at the end of this existing list individually, not as a list. Okay. So let me just print L1 again here. Now you see that the 6, 7, 8, 6, 7, 8, it is appended as a list, not the individual elements of 6, 7, 8 are appended to the list. It is appended as a whole list. It means the 6, 7, 8 is considered as a single element in the outer list. But this is not what we are expecting. We are expecting to add the individual elements of 6, 7, 8 to be added to this existing list of 1, 2, 3, 4, 5. Right? So how to do that? So to do that, we have a function called extend. To do that, we have a function called extend. Okay. So let me just try that. So I'm taking the list again. So instead of calling append here, call extend here. And you see that. Now the individual elements of this list 6, 7, 8 have been added to this list, not as a list. Right? So have you understood the difference between the append and the extend? Is that clear? Hello? Is that clear?
Yes, sir.
Yeah. So the next one, we'll see how to add or insert a slice of elements at any position specified. Like here, if you call the extend function and passing the list of elements, then it is appending at the end of the list, right? Suppose I don't want that. I just want to append at the location specified, like wherever I want to insert the slice of elements, I should be able to insert that. So how to do that? So to do that, let us take this. We just take this. Let's suppose I just want to insert this 6, 7, 8 at a particular index 2, right? Then you specify L1 of 2 is to 2. 2 is to 2. All right. So this is equivalent to you specify the list of elements that you want to uh, insert there, right? So whatever the existing elements at that location will be shifted to the right. Okay, now you can again print this L1 after this. Now you see that these are inserted at the second location. Starting from the second location, 6, 7, 8 are inserted, and the elements that were present at those locations are shifted to the right, as you see in the output, right? So this is how you can insert the elements at a particular location. So far we have seen how to create, how to access, and how to insert the elements into the list. How to insert the elements at the end, it means how to extend this, how to append the elements, how to insert the elements we have seen. Now the next one is the updation, means updating the existing elements. Updation, which means updating the existing elements. Suppose, let's say that this is the L1. Okay. Okay, let us reinitialize. So this is L1, and let's say that I just want to update 2 to 0. It means instead of 2, I just want to give 0 there, right? So how do I do that? Any guess? L1 of, what is the index number for 2? 1, right? So L1 of 1 equal to 0. So you can print L1. Now you see that that element is updated. Suppose if I want to update a slice of elements, then how do we do that? slice of elements. Let's say instead of 2, 3, 4, I just want to make them zeros. Instead of 2, 3, 4, I just want to put 3 zeros. So you can have an option. You have an option to do that. You can specify the slice that you want to replace and the corresponding values, right? So the slice that I want to replace here is 1:4, right? And it is equivalent to 000. List of 3 zeros I want to replace, right? Now you can see this, right? 2, 3, 4 are replaced with 3 zeros. Okay. So what happens if I don't mention the number of elements equivalent to the number of indices that I have mentioned, right? On the left hand LHS side of this assignment, right? So what happens? So see, for example, here I'm just giving 1:3. It means I'm just referring to the two indices, but I'm just passing 3 elements here. So in this case also, these 2 elements will be replaced with the 3 zeros, and whatever earlier were present in those indices will be moved to the right side. Okay, so you can mention the number of indices greater than or less than the number of indices, that the number of elements greater than or less than the number of indices that you have specified. Similarly, let's say I'm just giving here only, I mean, some 5 indices. I'm just referring to 4 indices, 1 to 5. Then I'm just giving 3 elements only. So this slice also will be replaced with all zeros, 1,000, right? So this is how you can update the existing elements, element wise as well as the slice wise also. I have shown you how to update. So far we have covered creation, insertion and updation. The next one is removing, right? How to remove the elements. How to remove the elements from the list. So let us again take this. This is L1. Okay, so there is a pop operation. So if you call the pop operation, it will remove the last element in the list. Okay, so I'm just giving you here L1 dot pop. Okay, then it will print 5, right? So this is the element that has been popped up, right? So now after this, if you print L1 again, you will see the updated list after removing this last element, right? So suppose if you want to remove a particular element that is located at a particular location, that is possible. Suppose if I pass the index number here, it will remove the element that is present at that particular index. So what is the element that is present at the index 2 in this updated list? 1, 2, 3, 4, 3. So it will just return 3, and after that if I print L1, it will have only 1 to 4, right? So it is just returning the popped up element, and after updation it is 1 to 4. Okay, so you have an option to remove element by its name also, I mean by its value also. Like for example, I just want to remove 2, right? So you can have print of L1 dot print is to print whatever that I am removing. So print remove 2, right? And I'm just printing L1 here. Okay, it's not returning anything. That's why I'm printing null. So after this, if you print L1, you see that 2 is not there, right? So you have an option to remove the elements by its value also, right? So this is how you can remove a single element. Okay, single element at the end or single element by using the index number or by using the value of it, right? So how to remove a slice of elements? How to remove a slice of elements? Okay, let us say that. Okay, suppose I just want to remove 2, 3, 4 at a time. Okay, I just want to remove this 2, 3, 4 at a time. There are 2 ways that you can do this. So one is you can have that slice, referring to that slice 2, 3, 4 means 1:4. So this can be replaced with an empty slice. Okay, and try to print this L1, and you have got only 5, which means that 2, 3, 4 slice is replaced with an empty list, right? So nothing is there. So 1 and then 5. Suppose there is another way of doing this same thing. Okay, I can show you that. I am again printing this L1, print L1. So instead of writing this, I am just writing here delete of L1 of 1:4. We can remove this. So this will also do the same. See that? Okay, just removing 2, 3, 4. You have an option to clear off all the elements in the list. Like for example, I just call L1 dot clear. Then after that print L1, you will see that there are no elements in the list. It is just removing all the elements in the list. You see that there is an empty list. Okay. Suppose if I just want to delete the whole list, not just clearing off it and maintaining an empty list. I just want to remove the list itself, right? I just want to remove the list itself. Then in that case, you can call delete space L1, del space L1. So if now you try to print this L1, you will see that you will get an error. You see that you got error. L1 is not defined because it has been removed. There is no list with name L1, right? I'm just commenting it out. This is how you can remove the entire list. All right. So we have seen, I think we have covered almost all the things, all the operations, how to create, how to access, how to update, how to remove the elements in the list. So now we will see some of the built-in functions. Okay, some of the built-in functions we will see now. So here I'm taking L1 equivalent to again this 1, 2, 3, 4, 5. Okay, so I will call L1 dot reverse. It means it will reverse the list. Now if you try to print L1 after this reverse operation, you see that it will be printing them in the reverse order 5, 4, 3, 2, 1, right? So you can even sort them. You can even count the number of occurrences of a single element. So we'll see them. Okay, you can even find out the maximum, minimum, sum, length, various things you can do it. Okay, so here let's take another list with some duplicate values, let's say. So let's take some 1, 2, 3, 1, 2, 4, 8, and so forth. Okay, so let's say I just call L1 dot count here. Okay, L1 dot count of what? What I want to count? The number of occurrences of 1 I want to count. So how many times this 1 is occurring?
3, 3.
3 times, right? So it should print 3. Syntax. Three. You see that? It is counting and returning you the number of occurrences. What is the minimum value of this L1? Minimum value, 1 only, right? Maximum?
5.
5. And what is the length of this list? Size of this list?
1, 2, 3, 4, 5.
5 elements and 6 elements. Total 11 elements, right? Length should be
Yes.
11. So 1 is the minimum, 5 is the maximum, L1 is the length of the list. Alright. So you can even sort them by calling the sort operation L1 dot sort. Okay. See that it is sorting them right in the ascending order. Suppose if you don't mention anything here, by default this reverse equivalent to false. Okay, it means it will be sorting them in the ascending order by default. So if you want them to sort them, if you want to sort them in the reverse order, not just in the ascending order, we just want to sort them in the descending order, then you set reverse equivalent to true. So by default, the reverse is false. Okay. So if you set the reverse equivalent to true, then after that you print L1 again. Now you see that it is sorting them in the reverse order. Alright. So like this you can sort the elements. Then I'll show you how to copy the elements. Okay. So before that, just give me a second. Give me some 30 minutes time. Okay. I'll just come back. Yeah, sorry for that. So we'll see how to copy the list of elements. Okay. So here I'm just taking one list. Let's say I'm just taking L1 equivalent to some 1, 2, 3, 4, 5. Okay. So this list I want to copy. Okay. So will this work if I assign this L2 equivalent to L1? Will this work? Let us see. I'm just printing both L1 as well as L2. You see that now both of them are same, isn't it? It means copying is working, but there is some small issue with this. Okay, let me demonstrate that issue. I'm making changes to L2. Means let's say L2 of 1 equivalent to 0. Okay, again let us try to print both this L1 and L2. Both L1 and L2. Now you see that what's happening here? What is happening? Whatever the changes that you're making to L2 are also reflected in L1. Could you see that? Could you make note of that? Agree? What are the changes that you're making to L2 are also changing in L1. But do you want this kind of thing when you're making a copy? Hello? Anyone? You don't want that, right? Whenever you make changes to one thing, it shouldn't reflect in the other one, isn't it? When you're making a copy. But what is the problem with this? The problem with this is that when you use this assignment operator, it will copy by reference. It means it is just referring to the addresses where this L1 elements are stored, right? So it means both of them are pointing to the same addresses. It means whatever changes that you're making to one list will also be reflected in the other list. Okay. Suppose if I don't want that, right? Then there are two ways of doing it. One possible way is that we just call L1.copy instead of directly assigning L1. L1.copy I'm calling. Now you see that before and after, before this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, after making changes to L2, only the second element in list 2 is changing, but not the elements in the L1, right? So this is copy by values, right? There is another way of doing the same thing. So instead of taking L1, you can take L1 of is 2. It means you're just copying the individual elements, not the not you're not directly assigning the addresses of the L1 to L2. All right. So here also, whatever the changes that you're making to L2 are not reflected in L1, right? So this is a copying. This is copying. Fine. So you can even concatenate two lists by using the plus operator. Suppose if I give L1 dot N1 plus L2, then you see that these two lists are merged together, right? So the plus operator can be used to merge the two lists and return a concatenated list. All right. So is that clear so far? Are you with me? So we've completed tuples, list. We'll move to the
Yes.
list data structure. Okay. So we'll see the tuples. So tuples are almost the same as the list. Only difference between the list and the tuples is that lists are changeable. It means you can modify them, right? Whereas the tuples are immutable. You cannot modify them once you define them. Tuples you cannot modify once you define them. So if there is any application where you just want to access the data but don't want to make any changes to the existing data, then tuples are much faster as compared to list in those cases, right? So because the way they store this tuple information is different from the way that they stores this list information, right? So here we'll be demonstrating tuples. So to create list, what brackets we have used? Square brackets, right? To create tuples, we use this parenthesis. To create tuples, we use this parenthesis. Okay. So how to create a tuple? Instead of taking the square brackets, take the parenthesis. 1, 2, 3, 4, 5. Right. So this is how you can create a tuple. There is another way also by calling tuple function. Also, you can do the same. So t1 comma and type of t1. 1, 2, 3, 4, 5, and this is of type tuple, right? Fine. There is another way of doing this by calling this tuple function. You can create a tuple. You can create a tuple. Both of them are same. So here I'm just taking t2. So here I'm just calling a tuple function on this. Okay, you can take a list as an input. List of 1, 2, 3, 4, 5 as an input. And here it is T2 and T2. So both of them are C. This is how we can create a tuple. And accessing the tuples are all same as in case of list, right? So the accessing tuples is equal similar to how we access the list. So because we have already demonstrated how to access the single elements, slice of elements, all those concepts can be applied in case of tuples also. So I can show you one of the example that uses the tuple, which is the div mod example. Div mod example. So here I'm calling a div mod function, div mod of 10 comma 3. Let's say. So here div mod means what? It is dividing this 10 divided by 3. It is performing, and it will return the coefficient value as well as remainder value. Coefficient value as well as the remainder model. So it is returning them as a tuple as you see here. So I'm just printing the return value of the div mod. You can see this. This is printing them as a tuple because the program doesn't want to allow they make the changes to this, because when you divide 10 divided by 3, always the coefficient is 1, remainder is 1. It will not change, right? So you don't want to make any changes to this results. That's why this is defined as a tuple, right? So this is of type tuple. All right. The next concept is sets. The next concept is sets. So sets contains the unique elements and they are unordered. And these are easy using sets. It is easy to perform various set operations like the intersection, union, set difference, and so forth. Right. So let me tell you how to create sets. So to create list, what brackets we have used? To create list, what brackets we have used?
Square
Square
brackets.
Square brackets. To create tuples, what brackets we have used?
Parenthesis.
Parenthesis. What we left with? Curly brackets. So to create sets, we use curly brackets. And dictionaries also we use the curly brackets. So if you give empty curly brackets, then it will take it as a dictionary, not as a set. Okay, so don't do that. If you want to create a set, you can give 1, 2, 3, 4, 5, like I mean something like this. You can pass the elements. You can even use the set function, right? So set of the list of elements you can give, that will also create the set. And let me demonstrate that set will not accept the duplicate values. So it will consider only the unique values, and they are not ordered, right? So here 1, 2, 3, 4, 5, and some duplicates I am giving like this. So now let me just print this as one and type of it. This is of type set. This is of type set, and you see that is it taking all the elements or unique elements? It's considering only the unique elements in that set, right? Right. It is not. No, it doesn't allow any duplicates. So S1 is this, and let us take another set S2. So S1 is this, and let me just take S2. Let's say it is some 3, 4, 5, 6, 7, like this. Okay. So let me just print S1 and S2 both. So these are the two sets that we are taking. So what is the intersection between S1 and S2?
3, 4, 5.
3, 4, 5. So we can call S1 dot intersection S2. This is returning you 3, 4, 5. Suppose if I use this union here, then
1, 2, 3, 4, 5, 6, 7.
1, 2, 3, 4, 5, 6, 7. Suppose if I use set difference, S1 set difference S2. What is S1 minus S2?
1, 2.
S1 minus S2 is 1, 2, right? Can you tell what is S2 minus S1? S2 minus S1. S2 minus S1.
6, 7.
6, 7. Six and 7. Alright. Like this, you can perform various operations. You can even perform, these are the true or false questions. Let us just print this L1 and L2 again for your reference. So this is L1, 1, 2, 3, 4, 5, and this is L2, 1, 0, 3, 4, 5. Okay, now answer this question. Is L1 subset of L2? True or false? L1 dot is subset of L2.
Oops.
No, right? So it means true or false? What it will return?
False.
False. Oh, sorry. S1, S2. Right? Set 7, I'm not taking this. Sorry. False, right? So this is 1, 2, 3, 4, 5, and this is 3, 4, 5, 6, 7. So is S1 subset of S2, right? This is false. Another question, is S2 subset of S1? S2 is subset of S1. This is 3, 4, 5, 6, 7 is S2. 1, 2, 3, 4, 5 is S1.
No, false, false.
This is also false. Another question, is S1 is subset of 1, 2, 3, 4, 5, 6.
Yes,
This is true, right?
yes.
Is S1 superset? S1 is superset of let's say 1, 2. So is S1 superset of 1, 2? Set of two elements 1 and 2. True or false? S1 is 1, 2, 3, 4, 5. Isn't it a superset of 1, 2? True, right?
Yes.
Okay, another question. S1 is disjoint. Is disjoint of this 1, 2. Are these two disjoint? Disjoint means what? There is no common element between them.
No, sir.
This should written false, isn't it?
Yes.
If I give instead of 1, 2, if I give 6, 7 here, then are they disjoint?
Yeah.
True, right?
Yes.
So like this, various set operations can be executed efficiently using sets data structure. The next one is the dictionaries. This is one of the widely used. Lists and dictionaries are widely used. I mean, in this, right? There are other data structures which are replacement for this list. Like we have NumPy arrays. Those are much more efficient than the Python list. Okay, so here I'll show you how to create a dictionary, then how to access it, how to update it, how to insert the elements into it, how to remove the elements from it. So all these basic data structures that we have seen and got this. So all this data we're gonna see that how to access, how to update, how to remove the elements from the dictionaries. So all the basic operations that we have seen for the other data structures, we'll also see for the dictionaries. Okay. So as I have mentioned to you already, if you give an empty brackets, by default it will take it as a dictionary, not set. Okay. So you need not even give the empty dictionary. You can directly pass the elements also to the dictionary. But that we will see later. So we'll initially take the empty dictionary and we'll see how to add the elements to the dictionary. These dictionaries are like hash data structures. Hash, you know, right? So you can access the elements with an order of 1 time, right? So and it has the key value pairs. So you can use the keys to access the corresponding value, right? So here I'm creating a dictionary and then I'm just inserting the elements into the dictionary. Two elements I am inserting, the key values I am specifying here inside the brackets. So d1 of 1, here you mention the key. So key I am giving here is when you 1 and this is equivalent to value. Value is 1. Similarly, you can give another value d1 of 2, two is equivalent to 2. Now you can print the dictionary and see that how it looks like. So this is the dictionary key value pairs. One key and numerical 1 is the value, TWO2 is the key and numerical 2 is the corresponding value. There is another way of creating this dictionary. directly you can, instead of doing all this process of creating empty dictionary and then assigning values to it, then if you have idea about the values already, then you can directly create the dictionary. So I'm just creating another dictionary D2 with this assignment, right? So, and I'm just printing this D2. See that both of them are same, right? So this is another way that you can create the dictionary. All right. So now how to update the elements or how to access the elements. So suppose if I just give print D2 of ONU1 here. So what do you think it will print? What is the value corresponding to ONU1?
Numeral 1.
1. Numerical 1 it will print. So this is how you can access. Suppose I just want to update numerical 2 to 2 2. Instead of 2, I just want to update it to 2 2. Right? Let me just print D2 also for our. So this is D2 which is printing this. Instead of 2 here, I'm just writing 2 2. Let's say. Okay. So here D2 of TWO2 is equivalent to 22. Okay, so you can print this. You see that? Not equal to equal to equal. See that now it is making changes, right? Here the value is changed to 22. So this is how you can update. Another way of updation also there, but let me just take this before that. There's some function called d2.update and specify the key value where you want to update TWO2 and this give the updated value here 22. Okay, so then now you can try printing this D2. You see that it is updated, right? 2 is updated to 22. Numerical 2 is updated to 22. So like this, you can perform the update operations in the Python, in the dictionaries. Then we'll see how to remove the elements. Okay. I'm just taking D2 here for our reference. So this is D2. For example, I just want to remove TWO2, right? So you can just take D2 dot pop TWO2. Okay, and you can now print D2 again. You see that this is before and after, right? Before there are 2 elements, after popping off 2, then you have only 1 element in the D1, right? So this is how you can pop the elements in the dictionary. Okay, then I will show you how to. I'll show you how to create a dictionary from 2 different lists of key value pairs. Okay, so here I'm taking keys is one of the list. Okay, and these are the values that comes as a keys values in the final dictionary. So here I'm just giving the values like ONE1, TWO2, sorry. So these are the values. Okay, and you can define the These are the keys. You can define the corresponding values also. Give me a second. Please let me have some water. Yeah, sorry about that. So these are the keys, list of keys that I'm giving here. Similarly, you can give the list of values also. And we want to create a key value pairs from these two different lists. Okay. So the values here is 1, 2, 3. Okay. So now I just want to zip them together. Zipping them is what? You take one element from each and create a pair, right? That's the zipping them, right? So I can show you this, what zip operation does. Zip of keys comma values. Okay, this returns an object. You convert that into list. Okay, in whatever data structure that you want. If you want to do that in dictionary, you can do it. Okay, you can see that it is generating key this one element from each one and creating a pairs, right? Instead of giving to list, if I give it to dictionary, DICT, then it will create a dictionary, right? The same way, right? Key value pairs. When one is the key and numerical one is the value. PWO2 is the key and numerical 2 is the corresponding value. THRE3 is the key and the corresponding numerical value is the value, right? So this is how you can create a dictionary using the two different lists. There is another way of doing this. By writing the loops also you can do this. So what should I take for I in the range of length of keys? So it means indexing starts from 0 and ends length minus 1. So it means 0 to 2, right? What I want to do, I just want to take what this dictionary. Let us take some empty dictionary D2. So the D2 of keys of I is equivalent to values of I. Okay, so done. Now you can print D2. This is also creating the same dictionary. This will also create the same dictionary. You see that this will also create the same dictionary. This is another way that you can create dictionary using the two different lists. Okay, one of the list will act like a keys, another list will act like a values. Okay, suppose if there is a dictionary, let us take a dictionary. Okay, so this is a dictionary, or let us take T2. This is a dictionary. Suppose if I just want to get the information about only keys, okay, then you can call D2.keys. D2.keys, you see that it is just accessing the keys 1, 2, 3. So similarly, you have an option to choose select only the values. So D2.values, then it will return you the list of values in that dictionary. You can even get the information by calling all the items D2.items. Then it will return you the key value pairs as you see here, right? So like this, you can have an access to the keys or have an access to the values individually or pairwise by using these items. You can also have the nested dictionaries. So let me take the nested dictionary. This is D2, right? I can print D2 for you. So this is D2. So now if I take this as a value in another dictionary, let me show you that. So I'm just creating a nested dictionary D3, which is an empty dictionary initially. So here I'm giving D3 of numbers. Okay, numbers is the key value in the outer dictionary. Numbers is the key value in the outer dictionary, and the corresponding value is this D2. Okay, so this is the dictionary of dictionaries, right? So when I print D3 now, you see that this is the outer dictionary in which the key value is numbers and the value is this inner dictionary. In the inner dictionary, we have again key value pairs. So now suppose if I just access this D3 of numbers, D3 of numbers, what do you think I will get? If I access this D3 of numbers, what do you think I will get? This dictionary, which is D2, isn't it? So if you want to get the inside values, then I can access here TWO2. Alright. So like this, you can even have the nested dictionaries also. Nested dictionaries also. Okay. So is that clear so far?
Sir, can you repeat nested dictionaries?
Yes, yes. Nested dictionaries, it is a dictionary of dictionaries, sir. So when you're accessing D3 of key value, which means these are the key values in the outer dictionary. It means it will return the value corresponding to this key value in the outer dictionary. So what is the value corresponding to numbers? That inner dictionary, isn't it?
Yes, sir.
Right. So it is just printing that inner dictionary. Let me just. It's just printing that inner dictionary, right? So now suppose if I just want to access the inner dictionary again, then you open another bracket and specify the key in the inner dictionary. Let's say 1 or 2, whatever that you want to specify. Then it will access that particular element in the inner dictionary. Got it, sir? So the first bracket must have the keys in the outer dictionary. Second bracket must have the keys in the inner dictionary. Got it, sir?
Yes, sir. Yes.
The next one is this you know it, but just for the sake of completeness, we'll quickly complete it. Operators and binary operators, right? We'll first see the different unary operators and then binary operators. So we'll quickly do it. You know this, except for 1 or 2, it is same as in the case of C, C++, Java. So A equivalent to C plus 2, 3 minus 2, C equivalent to some 5 divided by 2, C equivalent to some 5 star by 2, 5 star 2 is 5. I want you to guess what is the output that we get later. Later we complete this. F equal to 5 modulus 2 G 5 double star 2 H equivalent to 5 double division. Right? Okay, I'm just printing all of them. What A will print? A
5, 1, 2, 10,
5 5 1.
2,
Then
10.
C will print 2.5, right? 5 divided by 2 is 2.5. D will print 10. 5 star to 10, right? E.
Yes, sir.
Okay, E I gave it 2 times.
Yes.
I will not sleep today. Okay, E is 5 percentile modulus 2. This will be 1, right?
Yes.
You know what is double star?
Power.
Power.
5 to the power 2, which is 25. What is double division here? This gives you the coefficient value. So when you divide 5 divided by 2, what is the coefficient? What is
Integer
the
quotient.
remainder? Coefficient is the 2 value 2 and remainder is 1, right? So this will return 2. Yes. 5, 1, 2.5, 10, 1, 25, and then 2. 2 is the coefficient when you divide 5 with 2. Right. So these are the operators. We'll see the binary operators also. Few of them. just to give you an idea. So let us take two numbers, a equivalent to 5. Binary representation of this is 1, 0, 1. Let's take another one, b equal to 2. What is the binary representation? 0, 1, 0. So what do you get when you take a or b? A or b means what? At least if one bit is 1, then the resulting is 1. So here 1, 0, 1, 0, 1, 0. What is the resultant? All ones, isn't it? Am I right? Isn't it all ones? All ones means what? Are you getting my point?
7.
7. Yeah. This is 1, 1, 1. Right? When I take OR operation. Excuse me. Okay. So can you guess what will I get if I take A and B? All zeros?
0.
A XOR B? All ones again? XOR says what? If both are different, then the resultant is 1. If both are same, then it is 0. Right? So here in all the cases, bits are different. So it will. Can you guess what I will get if I perform right shift operation on A? One right shift. This will become 0, 1, 0, isn't it? It means 2. What happens if I do left shift on A? This will become 1, 0, 1, 0, which is 10, isn't it? So 7, 0, 7, 2 and 10, like this. They can perform various binary operations. Now the next one is the conditional statements. So how to write the conditional statements, we'll see. So we'll write if else conditions. Okay. We'll take an example of whether given number is an even number or odd number. Let us take the input from the user. So X is some input of enter some number. You're asking user to enter some number. Okay, you can just convert this into int by calling int. Okay. So now, what is the logic to write whether it is even number or not? If x percentile 2 equal to 0. What is this? Even number. Else, then it is odd number. Okay. So shall we execute this? This is the syntax. I'm just entering some number here. Let's say 5. This is odd number. I can re-execute it. Achha, to execute the code, I'm pressing shift plus enter. Okay, you can even press control enter, but it will not go to the next cell if you press control enter. Here I'm entering 4, shift enter, it is a even number. What if I want to write if, else if, and then else? Okay, we have else if also, right? In case of C in other languages that we know. We have else if also, right? So how can I write else if here? Else if keyword is elif. Else if keyword is elif and specify the condition here also. Suppose if this is modulus x modulus 3 equal to 0, then you can print and say that, oh god, what happened? Okay. Okay, so x modulus 3 is means it is odd. Is it odd? X modulus 3, yeah. It's odd, but So we'll just write it as this is not odd. It's not necessarily odd, right? Divisible by 3. Divisible by 3. Otherwise, we'll write it as a odd but not divisible by 3. Okay, so let us enter some number. Let's say some 5. Okay, is it divisible by 3? Is it even number?
Yes.
So to which statement will be printed?
Odd but not even.
Odd but not divisible by 3. Okay, if I execute this, let's say I gave 9 here, then which statement will print?
Divisible by 3.
Divisible by 3. If I give some even number here, then it will display the even number. It is even number. Like this, you can write if, else statements. We have the switch also. Syntax is very much similar to the syntax in the C language. We can go through it. The next one is the looping statement, loops. Okay, so we'll see the for loop. For I range, I in the range of, okay, before this, let me just, before I demonstrate with respect to range, let me just take some list. This is L1, right? Okay, I just want to print all the elements of L1. Okay, so to do this, what we do is that for each element present in this L1, just print that element. Print that element. 1, 2, 3, 4, 5. Right? It means what? Here you are passing the list of elements, accessing each element at a time and just printing that element here. Right? So now when I call, suppose if you want to generate the indices, there is a function called range. If I give range of 5, it will generate numbers in the range of 0 to 5. Okay. So I can give you the list of range of elements. You see that this is generating numbers 0, 1, 2, 3, 4, right? If you give a range as a 5, if I give range as a 6 here, range of 6, then what it will generate? 0 to 5, isn't it? If I give 7 here, please tell 0 to
0 to 6.
6. Okay, this is what it generates. Suppose if I give starting value also, range of 1 comma 7, then it will start from 1 and it will generate till 6. 1, 2, 3, 4, 5, 6. Now coming back to the loops, now we have this. So for I in the range of 5, it means it will take the indices values 0, 1, 2, 3, 4. Okay, you can just print I or you can access any other array using this index. Okay, print I. Or you can just print L1 of I, L1 of I, L1 of 0, L1 of 1 and so forth, which is 1, 2, 3, 4, 5. Alright. So like this, you can write loops. You can even write the nested loops also. Okay, so let me write nested loop here. I in the range of 5, and let us take another list. J in the range of this red color because we have given wrong indentation. For J in the range of 5, let's say some condition will put I range of 5, J range of 5. Total how many times this statement will be executed? 25 times, right? Right. So because if you print 25 numbers, it's difficult to see them. We'll reduce the number. If I less than J, I less than J, then only we will. You see that? Okay. Like this 0, 1, 0, 2, 0, 3, 0, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. These are the scenarios where I less than j, right? So like this, you can write the nested for loops also. If you want to write one-liners also, that is possible. Like for example, the whole thing I can write it in a single line like this. So I'm just giving this. This is what the end statement that I want to do, right? Printing. Alright. For I in the range of 5, you remove this column. For j in the range of 5, you can even remove this. And if I less than 3. So if all this happens, you have to print I comma j. See that. It's printing, right? She's doing the same as job as that. These are the return values, that all nuns. Fine. This is how you can write one-liners, and I mean loops can be written in the one-liners. All right. Similarly, the while loop. While loop syntax is same as in case of C. I can quickly write it for you. I equal to 0. Let's say while I less than or equal to 5. Okay, or I less than 5. While I less than 5. Inside this, I equivalent to I plus 1. Okay. Print I. Okay. The sum
0 for 4.
1, 2, 3, 4, 5. This like this you can write the for loops. Yeah, any query, Bhima?
No, sir. No, sir.
Yeah. Following, right?
Yes, sir.
Following or not?
Yes, sir.
Everybody?
Yes.
Did you follow it? Everybody? Are you following it or not? Are you with me so far? Hello? Anybody is there? Am I audible? Could you
Yes,
follow
sir.
it? I'm audible but not understandable. Is it so?
No,
No,
sir.
sir. No, sir.
Could you follow it?
Yes, sir.
Yes, following.
Yes. So we'll see how to define the functions. We use DEF keyboard to define the function. Okay. So sum of, I'm defining the sum function. As the sum keyword is already there, the notion is in Python is that if any keyword, if you want to write it as a function name or a variable name, you can give it underscore. Okay. So to avoid that confusion. So sum underscore I am defining. Okay. You can give some underscore 1 or whatever. Alright, some underscore I am giving. 2 numbers it is taking as input. Colon you specify here to follow the definition, to define it. So here is the definition. So I'm just defining C equivalent to A plus B. You can even directly also write, and return A plus B also you can write. So all the statements that are inside the function must be at the same indentation level. C, return C. Okay, so this is the definition that I've defined it. I just have to use it now. So sum underscore 2 comma 3. Okay. So this is returning you. Oh, this is taken as this box, not code box, markdown box. Somehow it got it. This is printing 5. You see. So now I will tell you how to write functions with some default arguments. You know the default arguments, right? Default arguments, if you don't pass anything, it will take that default value assigned to that argument. Okay, I'll show you one default argument. So here I'm taking one default argument C, and the default value for this is 3. I'm taking C equal to A plus B plus C. Okay, I'll take S here. Sum is A plus B plus C. S. Okay, I'm just returning this. Now, when I call this sum underscore of 1 comma 2 comma, let's say 3 comma 2 comma 3 comma nothing. Okay, I just gave sum underscore 2 comma 3. Right here I'm just passing the 2 values only, whereas the sum function is taking 3 values. Okay, so if you don't pass anything for the third value, by default it will take it as a 3. So what it will return? 2 plus 3 plus 3 means it will be returning 8. Right? So it returns 8. Suppose if I pass some value here, then it will not consider the default value. It will just consider this one. 2 plus 3 plus 7, it is total 12, it will return. Right? So the default arguments, you don't pass anything, then it will consider that default value. Right? So in lots of places we use this kind of thing, right? If I don't pass anything, you consider this as a default value. Like sorting function we have seen, right? If you don't set the reverse equal to true, then by default reverse is false. It means it will be sorting the numbers in the ascending order, right?
Yes.
So that's the default value that it is taking. At lots of places in default value, we use default values, functions and default values. Next, I'll show you how to write functions with some variable number of arguments. So functions with variable number of arguments. Okay, so here the input is the arguments I am taking, star args, let's say. I'm initializing s equivalent to 0, sum equivalent to 0, and I'm repeating it over all the arguments. So for each element in args, the arguments, what we want to do, s equivalent to s plus element. Okay, and just finally return s. That's all. Okay, this is with variable number of arguments. You can try it now. Sum underscore 2 comma 3. You will return 5. Sum underscore 2 comma 3 comma 4. You will return 9. Sum underscore 2 comma 3 comma 4 comma 5. You will return 14. 2 comma 3 comma 4 comma 5 comma 6. You will return 20 and so forth. So you can pass any number of arguments. Alright. So this is the function with a variable number of arguments. The next one I'm going to demonstrate is the anonymous function. Anonymous function. Okay. So I'm just, anonymous function means you're not giving any name to it, but you can use it at lots of places. But here I'm just assigning it to some variable z. Okay. So you can use z and call this function. So we use lambda as a keyword to define the anonymous function. This is taking two input values x and y, and it is returning x plus y. Okay, so here you can take it as some anonymous. Okay, some underscore a I will call some anonymous. Okay, so now I can use this sum underscore a and pass the two numbers, let's say 3 comma 5, and it will return 8. Okay, this is how we can define the anonymous function. So the next one I'm going to demonstrate is the map function, which maps the individual elements of a list to a function, some function that you specify. So let's take some values. Let's say L1 will take. So this is L1, right? Suppose I just want to create a list of strings. I mean, these numbers as a string. I just want to map them, right? Then you can call like this. Like for example, I can say that I call the map function to what I want to map, to the string I want to map, and what I want to map, I want to map this L1. All right. So this is what, okay, it will return you an object, but you can convert that into a list. Okay. Okay, let's call this as a M1. Okay. And I just print list of M. Okay. Now you see that all of them are converted to string, right? It means it is mapping each and every element of L1 to the string. It's converting that, and you are using that conversion. That returns an object, and that object is converted to a list by calling this, right? So this is the use of mapping. Similarly, like you can have anonymous functions and the map functions together. Let me take this. Let me take L1 equal to some 1, 2, 3, 4. And let's take L2, which is, let's say, 4, 5, 4, 3, 2, 1. Reverse. Okay. So when you sum up individual elements, you will get all fives, right? Right. So how to do that? So let me take the map function, map. Okay, what I want to perform? Addition, right? So you can define some anonymous function, lambda that x comma y. You can directly take that sum underscore a also, lambda x comma y, and then x plus y you are doing there. This is what you are doing. This is, I mean, you want to map these two lists to this function, right? So L1 comma L2. Now let us convert this map object to a list and print this. See, lambda all fives, right? See, it is mapping the individual elements of both the list to this anonymous function that we have defined, right? That's about the map. All right. Yeah. So far, what we have covered in this section. So in this section, we have covered data types. What are the data types that we have covered? I want you to respond. Integer, floating, complex, Boolean, one more, string, right? And then we have covered different data structures. What are the different data structures that we have covered?
Lists, tuples,
List,
list
tuples,
tuples.
sets, and dictionaries. So in each one of these data structures, we have seen how to create the data structure, how to access the elements from the data structure, and how to update the elements into the data structure, and how to uh, uh, remove the elements from the data structure. Okay. So in the tuples, I think something we missed there. Okay. That time, okay. What did we miss? I think accessing the elements is same as in case of list. Did I demonstrate the tuples? I don't remember. Yeah, I've demonstrated. All right. So accessing the tuples is same as accessing the list. That all slicing operations, negative indexing, everything can be done in case of tuples also. You cannot update them. Okay. So one thing I forgot to demonstrate, now I will demonstrate here, is that suppose you want to make changes to the tuple. Okay, let's say this is tuple 1, right? 1, 2, 3, 4, 5. I'm just making changes. T1 of 0 or T1 of 1 equal to 0, right? See that it will throw an error. Tuple object does not support item assignment. So you cannot directly update the tuple. Okay, they are immutable. They're not changeable, right? But if for some reason you want to do it, there is a way around it. It means you have to convert this tuple to a list and then update the list and convert it back to a tuple. Okay, so tuple 1, list 1 equal to list of this T1. It means you're converting this tuple to a list. Okay, that's what you're doing. And this is named as L1. Now you can call this L1 dot append 6, means you are making some changes to it, or you can change it also L1 of 2 equal to 0 or whatever. Now convert this list back to the tuple. So T1 equal to tuple of L1. Tuple of L1. Passing this. This is used to convert the list to a tuple. Now you can print before and after. Before anyhow we have already printed. After this, let me print. Now the tuple is 1, 2, 3, 4, 5, 6. So this is a way around, right? If you want to do in some applications or somewhere, then you can do this. Okay, but due to some reason, if you want to do somewhere, then you can do this. Fine. This is what I forgot there. And then sets we had discussed, different set operations like union, difference, set difference, intersection, is subset, is superset, is disjoint. Then we started discussing the dictionaries. Then how to create dictionaries using two different lists also we have seen, nested list. Then we have seen operators. Then we have seen binary operators. Then we have seen the conditional statements. Then we have seen the looping statements, for loop and while loop we have seen. Do while also, directly not there in Python, but you can simulate that using the while loop. And then we have also seen how to write the functions, with some default arguments, how to write the functions with variable number of arguments, how to write the anonymous functions, and how to use the map function to map the individual elements of a list to certain function. So these are the things that we have covered in today's session. All right. I hope you followed it. If you have any queries, I can take another 5 minutes, then we can wind up the session. In tomorrow's session, we'll cover NumPy, Pandas, and Matplotlib. Thank you very much and happy learning.
Thank you, sir.
Thank you so much, sir. Hello.
Yes, ma'am. Yeah.
Thank you so much, sir, for the hands-on session on Python programming. We enjoyed your session. We had a great learning experience. Thank you so much, sir.
Thank you, ma'am.
Sir, and also share the Jupyter
Yeah,
notebook just in
I'll
case
share
we
it.
missed.
I'll share